Hello everyone, this is Dr. Rajesh and I am again with you with my next video lecture, and in this video lecture we will deal with an important problem based upon the divergence theorem. So this is the surface integral and we have to prove that this is equal to that volume integral. So surface integral, we are going to take the surface integral and use the Gauss divergence theorem. So I am again writing the statement of Gauss divergence theorem. It states that surface integral over surface S of normal component of vector field F is equal to volume integral over volume V and divergence of vector field F over the volume V. So this is the statement of Gauss divergence theorem. Gauss divergence theorem. So now we shall try to prove the given statement. Let us take the right hand side. Going to take this integral. This is r vector dot n cap by r square ds. So this can be further written as double integral over surface has r vector by r square dot n cap ds. Now comparing it with this one. So if we compare here, f vector will be, so comparing will give f vector is equal to r vector by r square. So now applying the divergence theorem. So what divergence states that this will be equal to triple integral over volume V, and this will be divergence of this vector field. So this vector field in this case is this one. So this will be divergence of r by r square and over the volume V. Here you can write that using Gauss divergence theorem. We have obtained this one. Now we will try to evaluate. You may name it as equation number 1. Now we will try to evaluate this divergence of r vector by r square. So this thing is further equal to divergence, we know that is equal to del dot r by r square. So this can be further written as del dot 1 by r square, and vector field is written separately. So that way we can write. So now we will be using the formula and we assume it as phi, and this may be assumed as f vector. So I am going to use the formula and that you have studied. The formula is del dot phi is a scalar function and vector field f is equal to del phi dot f plus phi as such del dot f vector. So this formula we are going to use over here. So this will be, this is equal to del 1 by r square, and this will be dot r vector, and it will be plus 1 by r square del dot r vector. So this is, and now we are required to determine two things. One is gradient of 1 by r square, and second is divergence of r. And we shall name this equation as equation number 2. So firstly, we will be calculating del dot r is equal to, del is an operator, so I am going to write the value I curly by curly x plus j curly by curly y plus k cap curly by curly z dot, and r is a position vector and its value is this one. So this will be further equal to curly by curly x plus curly y by curly y plus curly z by curly z is equal to, and you know this is equal to 1 plus 1 is equal to 3. So this implies that del dot r is equal to 3. So that is divergence of r is 3. Now next we will be calculating del 1 by r square. So this will be equal to, so again write it as I curly by curly x plus j curly by curly y plus k cap curly by curly z. It will be 1 by r square. So this will be I curly by curly x. This will be 1 by r square, and we could use here summation. So this will be summation I cap. So this will be differentiation of 1 by r square with respect to x is, it will be, can be written as curly y because it is composite function. So we can write it something like that, curly r by curly x by composition. Okay, and this thing is further equal to I, and 1 by r square differentiation is minus 2 r cube, and curly r by curly x is x by r. So this thing is equal to minus 2 r4 summation xi. Now reopening the summation to r4, this will be x I cap y j cap z k cap is equal to minus 2 r4 r vector. Now we have obtained the value of both del dot r. This is the value of del dot r, and this is the value of del 1 by r square is equal to minus 2 r4 r vector. So we are going to substitute these values in equation number 2. So here it will be substituted. So what we will get? We will get a divergence of r by r square is equal to, now here we are going to put this value, and this will be minus 2 r4 r vector, and here will be dot, this will be dot, this is r, and this is enclosed in the braces, plus 1 by r square, and del dot r you have calculated is 3. So I'm going to put it over here. This will be 3, and we know that r dot r is r square, so this will be minus 2 r4, it will be r square plus 3 r square, because r dot r is equal to r square. So this will be further equal to minus 2 by r square plus 3 by r square. This will cancel out, it's r4, so 2 r r square will cancel out, it will be r square left. So this thing is further equal to 1 by r square. Now substituting this value in equation number 1, in equation number 1 we get this will value will be substituted. So now this will be double integral r dot n cap by r square ds is equal to, now this is divergence r vector by r square. Its value we have calculated as 1 by r square. So here we are going to put 1 by r square. So this thing is further equal to 1 by r square dv over volume v, and that was required to prove, that was required to prove, and this is over surface S. So this is important question from the examination point of view. And that's all I have from this lecture. And if you have liked the lecture, please like, subscribe, share and comment. This is Dr. Rajesh saying you goodbye, take care, bye bye, and see you soon.